Hello. In this video we are going to solve word problems using substitution. In the first part of lesson 7.1 we didn't have any word problems. I just wanted you to learn how to use substitution. But now we need to learn how to apply substitution to solve story problems. So these directions should look pretty similar or pretty familiar to you. I used almost the exact same directions when we graphed. We're just not graphing, we are using a different method. So it says read the following problems carefully, define the variables, write a system of equations, solve it using substitution, and then write your answer in a complete sentence. So here we go with problem number 1. Rihanna is older than Ken. The difference of their ages is 12 and the sum of their ages is 50. Find each person's age. Alright, so remember when you're defining your variables, you are asking yourself what you're looking for. So that's sometimes in the question part of the problem, or like the last sentence, or you're just asking yourself, what do you not know? And we don't know how old each person is. That's also what it wants us to find. It said find each person's age. So that is what we're looking for. So X is going to be like the age of one of the people in the problem, and Y will be the other one. Since Rihanna was first in the problem, we'll say that X equals Rihanna's age, and Y equals Ken's age. Okay. So you have to be able to define your variables. Remember, ask yourself what you're looking for. So now we're going to write our system of equations. 2 equations using the other information in the problem. It says Rihanna is older, okay. The difference of their ages is 12, and the sum of their ages is 50. Based on that one sentence there's 2 pieces of information, and that's going to give us our 2 equations. Remember, X and Y stand for their ages. So if the difference of their ages is 12, difference means subtraction, then that means Rihanna's age, and Rihanna's older, that's good. So Rihanna is X, and that means she's the bigger number. So X minus Y, Rihanna's age minus Ken's age, has to equal 12. That's the first equation. And then the sum of their ages is 50. Well, that's just X plus Y equals 50. Because sum means add. Okay, so now you have your system of equations. We are going to solve it using substitution. You actually have a lot of choices here. Neither one of your equations tells us that X equals something or Y equals something. So we're going to solve one of them for X or Y. And like I said, you have a lot of choices. I'm going to choose to just take the first equation and solve it for X. So in this first equation, I'm going to add Y to both sides. And off to the side here. That becomes X equals 12 plus Y. I like to write it as Y plus 12. So now that that equation is solved for X, I'm going to plug in what X equals Y plus 12. I'm going to plug that in for X into the second equation. So that will give me Y plus 12. I like to put that in parentheses, although the parentheses aren't really going to matter. So Y plus 12 and then plus the other Y equals 50. So there's nothing to distribute. So like I said, those parentheses don't really matter. But combine your Y's. You have a Y in the front and then a Y right before the equal sign. So Y plus Y is 2Y. And then you have the plus 12 equals 50. Get Y by itself, so subtract 12 from both sides. 2Y equals 38. Divide by 2. And Y equals 19. Now, just like the other problems we had when they weren't story problems, you have to find out what both x and y equal. Y equals 19, and remember Y stands for Ken's age, so we know Ken is 19. So you have to figure out how old Rihanna is. You have some options on where to plug in your 19. You could go right up here into this equation. You're plugging it in for Y. Let me redo that. Right up here. You could plug that in. If Y equals 19, well, then you could say, well, X equals 19 plus 12. And 19 plus 12 is 31. X equals 31, and that would be Rihanna's age. And you want to make sure that that makes sense in the problem. The difference of their ages is 12. 31 and 19. 31 minus 19 is 12. And their sum is 50. 31 plus 19 is 50. So our equations were right. We solved them correctly because that came out right. We just have to write our sentence. So find each person's age. So you know their ages. Now we have to just put that into a sentence. So your sentence would, want to answer the question. So I just wrote Rihanna is 31 years old and Ken is 19 years old. You want to make sure that you say that correctly. If I would have switched them accidentally and said, well, Ken is 31 and Rihanna's 19, that's wrong. So make sure that as you solve them, you understand what each of your solutions stands for. The X is 31, that's Rihanna. So Rihanna is 31, the Y was 19, that's Ken, so Ken is 19. Alright, we'll move on to the next problem. Okay, football people, this one's for you. At the end of the 2000-2001 football season, so that was a while ago, 31 Super Bowl games had been played with the current two football leagues, the AFC, the American Football Conference, and the National Football Conference, the NFC. Now, at that time, the NFC had won 5 more Super Bowl games than the AFC. And the question is, how many Super Bowl games had each conference won? So, remember, our first step is to define our variables, and we can usually figure out what to say for X and Y based on what the question is asking and what we don't know. We don't know, or it didn't tell us, how many Super Bowl games each conference had won. That's what it's asking. How many Super Bowl games had each conference won? So I'm just going to say that X equals the number of Super Bowl games that the AFC won. And then Y will be the number of Super Bowl games that the NFC won. Okay, so now that I have my variables defined, X is for the number of games that the AFC won, Y is the number of games that the NFC won. Now we're going to write our two inequalities. So in the very first sentence, it talks about the year, which that really doesn't even matter, but it says that 31 Super Bowl games had been played with the current two football leagues. So we know that altogether there were 31 games. So we know that however many games that the AFC won, X, plus however many games that the NFC won, Y, equals 31. There were 31 games altogether. So there's one of our equations. The other one is a little bit trickier to write. I'm going to switch to blue here, maybe. And it deals with one of the, well, I guess it's just the second sentence. That first sentence was long. The NFC had won 5 more Super Bowl games than the AFC. So the NFC is our Y. So Y equals 5 more than the AFC. So that would be like X plus 5, or 5 plus X. Okay, because the NFC is equal to 5 more than the AFC. The AFC is X. Okay, now at this point we have our system of equations. So we have our two equations here. And one of them, the second one, is already ready. It is solved for Y. Y is by itself. So I can take the X plus 5 and I can put it into the first equation right where the Y is. So that first equation is going to become X plus not y, but x plus 5, because y equals x plus 5, and then equals 31. And I think we had this in our first example where I don't really need those parentheses now because this is all plus and there isn't anything to distribute, but I can just kind of ignore those parentheses and just combine like terms. So x plus x is 2x, and then we have the plus 5 equals 31, and then we solve for x. So subtract the 5. Should have this solving part down. 31 minus 5 is 26, and divide by 2. 26 divided by 2 is 13. You can use your calculator if you need to as you do problems. I don't care if you use the calculator. Just make sure you show your work. So now that I know that x equals 13, I want to go back over to my equations. I want to figure out what y equals. So why don't I just put that into that second equation? If x equals 13, then y equals 13 plus 5, and that's just 18, so y equals 18. So now we need to go back to our first step, and that was where we defined our variables. We need to make sure that our sentences say exactly what those numbers mean. So x equals 13, so that means that the AFC won 13 Super Bowls, and the NFC won 18 Super Bowls. So we're going to write that into a sentence. Okay, so you just want to make sure you write your answers into a sentence that makes sense. And that was a long time ago, 2000, 2001. So some of you that follow football might know how those numbers have changed. But as of that time, the AFC was behind. They had only won 13, and the NFC had won 18. Super Bowl games. Okay, so let's move on to example number 3. Oh, this example is very similar to some of those that we did back when we were graphing. So hopefully with this example you'll be thankful that you don't have to graph it. But it says movie tickets are $8 for adults and $5 for children. A family purchases 10 tickets for $68 total. How many adult and children tickets did the family purchase? So we want to know, well, those are our variables. We want to know how many adults went and how many kids went to the movies. So again, when you define your variables, you're just looking basically at what are they asking for? What do we not know? And we don't know the number of adults and the number of kids that went to the movie. So that'll be our x and our... Okay, so make sure you write down what your variables equal. X equals the number of adult tickets and y equals the number of children tickets. Make sure that you are specific. Don't just say x equals adults and y equals children. That doesn't tell me enough. You need to be more specific than that. Alright, now remember back when we graphed, I talked about how if there's money, like we're talking about two things here. We're talking about how many tickets they purchased, but there's money involved as well. So all of those money numbers are going to be in one of your equations. And so that should be pretty natural to you. 8x, because adult tickets were each $8, plus 5y, the children tickets were each $5, and they spent $68 total, so it equals 68. The other number in the problem is that they purchased 10 tickets. So for that equation, you're just going to use that number. So they purchased 10 tickets altogether. So the number of adult tickets plus the number of children tickets equals 10 tickets. Okay, so now we're ready to not graph, because we're not graphing. We are ready to start solving, but neither one of our equations is ready yet. We have to get one of them ready. Hopefully you can see that the second equation would be easier to solve, and you can choose if you want to solve it for x or solve it for y. I'm going to choose to solve it for y. I just chose that. So if I take this second equation and just get y by itself, that means I would subtract the x. So that means y equals, technically you can write 10 minus x. I'm going to write it as negative x plus 10. And so that is now my, second equation. It's ready because y is all by itself. I'm going to take what y equals and I'm going to substitute it in for y into the first equation. So that first equation is going to get a little complicated looking. It's still going to start with 8x. And then it's going to say plus 5 parentheses, because in place of y we are putting negative x plus 10. And then it equals 68. Alright, so then we distribute. This will be a negative 5x and a plus 50, right? Yeah. Equals 68. Okay, and then 8x minus 5x is 3x plus 50 equals 68. Just solving for x here, minus 50. So 3x equals 18. Well, this will be nice. Divide by 3 and x equals 6. Remember what x stood for? X was the number of adult tickets, so we know they've purchased 6 adult tickets. I don't know where I got 8. They purchased 6 adult tickets. So then for the number of children tickets, I would just go back to my original second equation, drawing some arrows here. Right here, x plus y equals 10, so just put 6 in place of x, so 6 plus y equals 10. Subtract the 6, and y equals 4. And so your sentence would need to explain what those answers meant. So x equaled 6, so that means the family purchased 6 adult tickets, and y was equal to 4, and so they also purchased 4 children tickets. Alright, let's do our last example. Here we have a shopping example. A student bought 1 box of crayons and 5 reams of paper for $54. Another student went to the same store and bought 5 boxes of crayons and 3 reams of paper for $50. We want to know what is the cost of each box of crayons and each ream of paper. So, define our variables. Same process, 4 things to do. Define our variables, write our equations, solve using substitution, and then write our answer in a sentence. Okay, so what are we looking for? Well, here's our question. What is the cost of each box of crayons and each ream of paper? So, x equals, this time our variables actually do equal a cost. That's something we don't come across very often. Usually it tells us the cost of each thing. But this one doesn't. X equals the cost of a box of crayons. And that means y equals the cost of a ream of paper. If you don't know what a ream is, it's just a pack of paper, like copier paper, white paper comes in a pack of 500. Cost of a ream of paper. Okay. Alright, now we need to write our equations. Each equation is just going to deal with each student. The first student bought 1 box of crayons, so that's 1x, and 5 reams of paper, 5 plus 5y, and they paid $54 for that. The other student went to the same store, bought 5 boxes of crayons, so 5x, and 3 reams of paper, that would be 3y, for $50, so that equals 50. Now, to use substitution to solve these, one of our equations has to be solved for one of the variables. Neither one is like that yet. We don't have one equation that says x equals something or y equals something. But if you look at the first equation, that 1x, remember the 1 can just be invisible. We don't really need it. So we could have just had x plus 5y equals 54. So it's going to be easiest if we take that first equation and we solve for x, and that would just mean that we just take away the 5y there. So that first equation, remember 1x is the same as x, so it's going to become x equals, and you could write 54 minus 5y. I like to write the y first and put negative 5y plus 54. You could do it the other way, and if you're careful, you should get the same answer. But now that we have that equation solved for x, then we take what x equals, we put it into the second equation, right where the x is. So that's going to become 5 times x, which is negative 5y, plus 54, and then plus the 3y, that's still in the blue equation, and then equals 50. Then we distribute, so negative 25y, 54 times 5. Again, feel free to use a calculator, because I am. 54 times 5. 270. Then plus the 3y equals 50. Okay, combining our y's, negative 25y plus 3y is negative 22y. We still have the plus 270 on that side. We'll get rid of it next. And then right now it equals 50. Okay, so now we want to get the y by itself. So subtract 270. Oh, this will be nice. Negative 22y. 50 minus 270 is actually negative 220. So when you divide by negative 22, everything will turn out positive. If you get negatives, like during your problem, hopefully they'll turn out to be positives. If they don't, you need to check your work, because you can't have like a negative cost of a box of crayons or a negative cost of a ream of paper, or like in example 3, we couldn't have gotten any negatives there because you can't have a negative number of adults or children. So with real world problems, you're not going to see very many negatives. If you have them within the problem like we do here, they should at some point cancel out like these do. So those will cancel here, and you'll get that y equals positive 10. Okay, and remember y stands for the cost of a ream of paper. So a ream of paper is $10. Now we have to figure out how much a box of crayons is. Okay, so if y equals 10, we have to plug that into one of our equations from the beginning of the problem to find x. You could actually do it right here. You solved this first equation for x, so x is by itself, and so you can plug your y into its spot and just do a little bit of math here. So this will be x equals negative 5 times y, which was 10, plus 54. X equals, let's see, that's negative 50 plus 54. Good, that'll give us a positive 4. A box of crayons is $4. So now just write your those two answers in a sentence. Okay, so your sentence might say, a box of crayons is $4 and a ream of paper is $10. Okay, those are our notes on story problems. So now you're going to do assignment number 2.